Welcome to the DEEPMED seminar, a monthly forum on Mediterranean science, strategy, and environment hosted by the ERC-funded project DEEPMED. Today, we are very happy to welcome Stathis Arapostathis from National and Kapodistrian University of Athens. He's a professor of history and philosophy of science there. He started out as a physicist, and then he moved towards history and philosophy of science related to physics, but not only. For instance, his dissertation with Robert Fox at Oxford was on the British electric system, and since then he worked quite a lot on patent systems with very top people like Graham Goodey, and he's published very top research on that field. But I think that in the last years, maybe, he's moved to what he's going to be talking about today, which is weather modeling. In particular, he's going to be talking about weather modeling in the Eastern Mediterranean. So, Stathis, when you're ready, we are ready. Thank you very much.
Okay. Should I share my screen?
Absolutely, yeah.
Okay. Can you see it now?
Yes.
Okay. Thank you so much, Lino. It's a great pleasure to give this talk to this highly esteemed group and an excellent project, ERC project. I need to apologize that I could not attend this seminar series in person because of some recent health problems, and I decided to take a little bit more cautious, to be a little bit more cautious and not traveling a lot the last couple of weeks. So I apologize for this because the plan was different, but I really like to thank Lino for giving me the chance to give the seminar online. Thank you for the introduction. Actually, this is a parallel project. The last couple of years, I'm working on the interface of environment, science, politics, and policy. I'm running two projects, which are completely different from what I'm presenting now. This is, as I said, a parallel project that I was involved the last 2 years as co-investigator. This needs to be finished soon, but because of my other engagement, this has been delayed. And this is the last 12 months. It's always a work in progress. So I took this chance for this seminar just to wrap up a little bit my research and push it towards the end. As the title denotes, this is about talk about weather modeling as knowledge politics in Southeast Mediterranean, with an emphasis on Greece. I will raise and explore issues on expertise and politics of infrastructures that really are at the center of my research agenda the last couple of years. While meteorologists, they are always the last couple of years, and particularly in the Greek public media, at the headlines, and there were battles about their credibility, their predictions, and the impact of their predictions, as they won a recent battle about the weather during the Greek carnival, or or about their prediction of severe events like severe flooding, the recent severe flooding a year ago in the region of Thessaly, or other critical events like dust storms in Greece and Southeast Mediterranean, like the Red Minerva that happened a year ago in April 2024, that really create apocalyptic images in Athens, but also all around Greece, or 6 years earlier, the Red Minoan dust storm in Greece and Southeast Mediterranean that really again created equally apocalyptic images in Athens, but most importantly in Crete. While there is a continuous public interest about the credibility, about the trustworthiness of the meteorologists, I'm looking a little bit from a different angle. I'm looking the story of numerical weather prediction, the emergence of numerical weather prediction since the 1980s in Greece, and how research politics, infrastructure politics, knowledge politics co-evolve or co-produce with research policies, state research policies, as well as European research policies the same period, and how agendas of different research groups really played a key role in shaping numerical weather predictions, the credibility of modeling, and also the credibility of the groups. As I said, dust, the last 10 years, dust and dust predictions really is a key matter of concern, to use a Laturian term, for public media, but also for policy. As we see here, there are reports about the impact of dust storms in healthcare system, in aviation, in energy system. And one of my arguments is that dust really played a role in the legitimization, epistemological legitimization of specific numerical weather predictions in Greece. And I will say some more about this in the coming slides. So the structure of the paper, I will introduce with some historiographic comments, or let's say my analytical approach, give a little bit, let's say, the points of my analytical historiographic approach. Then I will present the emergence of numerical weather predictions and forecasting, and try to present as act of bricolage. Then I will move to how dust really and prediction of dust really matter in the research politics of specific groups, and then how dust really matter in shaping alternative research politics in other groups, and shaping agendas of scientific imaginaries in the Greek research community, and then conclude with some remarks. The argument, I would say, is that numerical weather prediction in Greece co-produced with, let's say, agendas of commercialization, and assetization of expertise in several atmospheric physicists groups, research groups in institutions, research institutions and academic institutions in Greece. Research questions how material and political conditions matter in the emergence of numerical weather predictions, more particularly how does prediction emerge in a country in the European periphery, and how numerical weather prediction, and more particularly dust predictions, have been co-produced with the emerging new roles of atmospheric physicists and the new ethos of technoscientific capitalism. In terms of my analytical approach, I would say that I'm rather eclecticist. I'm using and have inspiration a lot from the actor network theory and the concept of socio-technical assemblages and heterogeneous engineering as they have been introduced by Bruno Latour and John Lowe, where they emphasize how scientists and engineers put things together and really create an environment and play a role in the technopolitical setting in research, in science research. Also, I'm using the concept of bricolage as it has been introduced by leading historian and sociologist Mario Biagioli, and I'm using this concept trying to argue that numerical weather prediction is inherently a bricolage activity. And in this bricolage, always the commodification and assetization went hand in hand and really informed the activity of bricolage enacted by scientists and researchers. So numerical weather prediction, the story starts with this guy here, this chap is George Kallos, mathematician, professor in the University of Athens, my university, and the leader of the atmospheric modeling and weather forecasting group. Practically, he brought, let's say, numerical weather prediction in Greece since the early 1980s, and since the 1985 and up to 2021, 40 researchers and technicians really worked with him, and his group and the lab became a center of research for numerical weather prediction, and it was admitted, and it is admitted by researchers, Greek researchers, that he is really the one who introduced numerical weather prediction, and that they were educated by him, or most of the leading scientists in the recent years, they have been educated by him. In the 1980s, I would, let's say, focus on three instances of his activities and career. So when he is coming in Greece from Colorado and United States, where he finished his PhD, he was involved in three, in the 80s, three key for me, let's say, projects: the environmental evaluation and prediction of a power plant in central Greece, the evaluation of the Athenian smog and predictions there, and the trilateral project in the early 1990s between Greece, Turkey, and Israel. In relation to the evaluation of the industrial plant in central Greece, why it is important? It is important because he had for first time the challenge to use software and a model that has been developed in the United States and in the Colorado State University, where he was working before, to use that mesoscale model for the local intricacies and the local conditions in central Greece, in Corinthian Gulf, where there the challenge was to adjust the model, taking into consideration the complex terrain for the distribution of the aerosols, the pollutants from the power plant. So this was a key moment for his practice because terrain and the complexity of terrain had to be included and integrated in the equations of the model and the adjustment of a foreign model and the appropriation of a foreign software model for the local needs and for the local characteristics. The second, let's say, instance of his career is the modeling of air pollution of the Athenian smog, huge social political problem in the late 1970s and 80s. I'm not getting there, but it was a huge political and social problem. Attracted the interest, the funding of the state, of the research activities of several groups. But for him, the challenge was prediction of the circulation of pollutants in the Athenian region and the metropolitan region. So the key moment for why I see it as a key moment for the introduction of numerical weather prediction is that because he managed to persuade IBM Elas, a big company, to fund his research and and with this funding, he managed to buy computer infrastructures for his lab, but because funding was not very a lot. With the money that he had, he tried and managed to run models in distributed memory systems. So used the concept of parallel computing. And this is very important because in this way you can use many small computers rather than build a big super computing. And this is important because as we will see when he builds the first numerical weather prediction, the Skiron prediction system, it was a system for parallel computing and distributed memory system. So the trilateral project, as I said, in the early 1990s, was important because, according to him, he managed, and the interviews that I did with him, he managed to, let's say, set networks in Southeast Mediterranean, very important for him, exchange data, but also for him, it was important because it established the credential for project implementation. So this was a key concern for him, for a young researcher that was coming without funding in a country that really in the 80s start to think about having science and technology policy, how to build the credential in order to ask money from the state. Before going to this instance, and I need to set a little bit the setting of numerical weather prediction and forecasting. It is important to say that the Yugoslavian team from Belgrade University played a key role by setting ETA, the system that they developed, and this system integrated topography into modeling weather predictions and into having a system that can be adjusted to local climate. This was valued by United States, and in the 80s, it was integrated in the predictions of the national weather services in the United States, and Theodore Messenger and Zaviza Janic, the atmospheric physicists who developed this in Belgrade, really migrated to the US. It's a story covered by Yankovic in a fascinating paper, but it is important to understand that people in the Balkans at that period having shortage of money, but capacities and capabilities in terms of knowledge and research, they promoted different alternative models that integrate topographies into the models and also try to make codes and models that did not need a lot of memory and computing infrastructure. This really made them a key, let's say, key characteristics of their practice. And this really made them very marketable in the US system and gradually in global networks of weather prediction. I'm saying so in order to understand that in this setting, you have Kallos that really want to stay in Greece and create a model. He sees that what was happening because he's in communication with the Yugoslavian team. And also he sees a state that tries to set science and technology policy in Greece for first time. So in the 80s, you have institutions, new institutions, the establishment of the Department of Research and Technology Policy, funding schemes, and strategic programs of research and technology that really set an agenda of research policy that link academic researchers with innovations, with industry, thus started to promote technology transfer and the linkage as an inherent characteristic of researchers and research practice. Skiron thus, Skiron, the first numerical weather prediction developed by Kallos and his scheme was funded within these, let's say, strategic programs of research and technology that was funded by the state through the General Secretariat of Research and Technology, and the aim was to promote strategic alliance of industry and the research ecology. Where is the industry here? Industry was the National Meteorological Service. So the strategic alliance was to bring Kallos within the National Meteorological Service in order to design a model, Skiron, that was called Skiron, in order to, let's say, push an independent numerical weather prediction in Greece. And that was the framing of how they frame the project of Skiros. Skiros, as I said, Skiron was a bricolage act. Why? Because it was based on the ITA model as it was developed by the Yugoslavian team. And what they did, it was to adjust ITA model into the local conditions of Greece to provide full physics atmospheric parameters and variables, and also to, and I quote here, Kallos, to make easier topography preprocessor in order to secure its adjustability to many places. So physical processes and physical parameterization really were the key characteristics of Skiron that differentiate Skiron from ITA. And the second difference was that from vector computing, Skiron was designed for distributed memory in local networks of PCs. So small computers, it could be run in small computers. And why he wanted and designed it like that? Because he lacked infrastructures of big computing capacity. Oops. This is the area of that covered the Skiron, and Skiron managed through coding and clever coding to reduce the resolution of the prediction to 2 to 3 kilometers from what ITA could do. And as I said, adjusted the ITA model to distributed memory context. Dust to Skiron is coming in the late phase of the development of Skiron in the 1995 between 1995 and 1998. With what excuse? And the excuse was a project called MEDUS, a European project that Kallos got in order, with the collaboration of the Torre Majorana Foundation and the Center for Scientific Culture, to educate North African forecasters on Skiron, in order to go back to their countries after 3 to 6 months and let's say, as to use his word, to liberate local forecasters from the dominance of national weather meteorological services. And with this excuse, and because the concept was to educate North African forecasters and Middle East forecasters, he had to integrate dust into Skiron. And dust input was important, as we will see in the coming slides. From the start, Skiron for him was or had to be open, and this was part of his role and agenda. Open data, open open code, and this was the first conflict within the team because the IT designer wanted to keep it secret. But for him, Kallos demanded the openness of coding. He provided the code to the American Atmospheric Physics Organization as a part of principle, but also as a strategy in order to get credibility and be able to bargain data with code. So opening the code, he could negotiate data with the Americans in order to have access to their data, and not only to Americans, but as we will see, to other institutions and countries. He had some conditions. He wanted open code to open to those to users that would not use for commercial purposes the code, won't be competitors and antagonists to his research team, but also won't think to close the system and trade it afterwards. As he said, we did not build a software to keep it for us. And as I said, openness was part of the agenda and strategy for getting credibility. So it opened the code, it sent the code to different research center, and also he got from them data, but also by opening the code, and he could bargaining hardware with IBM and Hewlett Packard, because the idea was by opening the code and integrate it in the code in the system, they could test the computing capacity of their machines. So in this way, he can get hardware in his lab to do this activity, because exactly he didn't have money to have big computing infrastructures. Dust was important for that activity, and he said that the great asset of our lab is the dust prediction from Sahara to East Mediterranean that creates considerable problems in particular months of the year. So dust, he really promotes Skiron with dust, but I believe this was important for him because he started to look at Middle East and North Africa as big users of his model. He got the chance to build the credibility and the network of the lab and the credibility of Skiron with the Olympic Games. There were a lot of competition, conflicts between meteorologists and meteorological services and groups. There were three centers, the Hellenic National Meteorological Service, the National Observatory of Athens, and the National Kapodistrian of University, and they were battling for funding because things were delayed due to these conflicts. The government decided to give Kallos with the Hellenic National Meteorological Service and funding in order to build a weather numerical forecast system based on Skiron and dust, but this should have kept in secrecy with no publicity, and but for him it was not a problem because he managed to build infrastructures in the University of Athens, but also he managed to expand his cycle of credibility by expanding the networks to sailing teams, Olympic sailing teams, but also to big industrial actors and users. While he set this agenda of promoting Skiron for big users, in the same time he had a conflict with and battle with the Hellenic National Meteorological Service. They started to distance from him and his numerical weather prediction. They promoted Cosmos after Olympic Games, and they promoted the Cosmos numerical weather prediction, a system that was built by a consortium of the state meteorological services in Germany, Switzerland, Poland, Russia, and Italy and Greece, but it was not an open. It was rather a quasi-closed system that Kallos didn't really like this approach, and also it was a very competitive to his own numerical weather prediction system, Skiron. For him, openness, it was a matter of principle, but also it was a matter in order to boost an agenda, a strategy of bringing new applications, design for new applications and new services. I'm skipping this. As I said, he promoted an open science agenda. Skiron code had to be open. He didn't like commodities in numerical weather prediction services, but what he really pushed forward for his team and his research agenda was products tailored to large-scale users and their needs. So open meteorological data, open access to forecasts, open access to codes, but not commodity and popular science, big industrial users, tailor-made codes for them, and the warning and formal predictions only to the National Meteorological Services, and they should have reliability. That was the agenda, that was the idea of his strategy, a very different from what the National Meteorological Service did, or the National Hellenic Observatory that created the Meteo GR in 2010, a site where you can find specialized predictions for a wide range of users and for the large public. Dust, as I said, became the key, let's say, vehicle in Skiron in order to promote this strategy and really build on increasing accuracy of dust prediction by bringing chemistry into the model. Very difficult. I'm not staying on that, but also integrating different particle sizes and distribution of the different particle sizes, different sizes of particles of dust in the calculations. As I said, he was start looking at the Middle East and North Africa or East North Africa. And after the Olympic Games, he set a very big deal with the Saudi Aramco Petroleum Company contract and the big contract. And he had access, exclusive access to geophysical, geographical data, accurate geological maps. And this really boosts further the credibility of Skiron, but also of his team to build these large users products. And they had expanded the network in the Arab world, setting the climatic database in Saudi Arabia, and also they had contracts with the Qatar regional modeling system. And the key concern for them and the critical object of inquiry the last couple of years, since 2017 and up to 2021, it was how to, let's say, predict haboobs, which was they are very intense dust storms carried by the wind of the weather front, and to integrate those predictions into the Skiron. So we are talking about a system builder, but a system builder that really had an emphasis on applied science and commercialization as key and inherent characteristic of his practice in order to manage to do science and also to build the credibility of his lab. A different approach someone can see the last 15 years by another institute, the Institute for Astronomy, Astrophysics, Space Applications, and Remote Sensing, that is led by atmospheric physicists. They promote the agenda of, they have a system approach, but they link this system approach with open science, excellence, and blue sky science, rather than applied science. But in a peculiar way, as I will very briefly refer in the coming slides, products are always inherent to their research. So this group, they dealt with numerical weather prediction. They built on dust. They acknowledge the importance of Kallos, but the emphasis is how to build observations and models as an inherent system in a specific research institution. So they use LiDAR observations, which is laser that they send and they scan the atmosphere so they can have data for different layers of the atmosphere. And they built also in-house modelers. So they connect modeling with observation, but also even instrumentation, because they work very closely in collaboration with a company called Metrics. As I said, they promote the idea of open science, excellent science, and they were behind the whole campaign of building Antikythera, a small, tiny island in South Greece as a center of calibration of models in Europe and particularly in Mediterranean, a certification model, at the center of excellence of data management and modeling, particularly with an emphasis on dust. This idea resonated well, this agenda, research agenda of excellence, open science, excellent science, but also basic science, resonated a lot and well with the European agenda that developed it since 2014 onwards and migrated as an agenda to Greece after 2015-16 with the agency of the Minister of Education in that period, Fotakis, a leading physicist with a key role in European policies, that became a Minister of Education in the first left-wing government, and Fotakis promote the idea of linear model. So I put money and I create institutions of basic science, and this is the prerequisite in order to have scientific and economic development, growth, and added value. And this is the idea of the group also, that we are doing basic science, excellence science, and this can resonate with the issue of regional development too. So the as a rather different version of the linear model of science research existed both within the group, but also in the public sphere, the period of 2015-2020. What the group did in relation to dust, as I said, blue sky research, that means ERC, they were very keen in winning ERC, and dust as a key component of the research agenda to promote and increase credibility of numerical weather prediction. And on that, the last couple of years, what they were looking of the transportation of dust from Sahara, not only to Med East, to Southeast Mediterranean and Europe, but also to the Gulf, Mexican Gulf. So the transportation of the particles of dust in the transatlantic transportation of dust. And what they promote as a hypothesis is that particles of dust, they travel not only with wind, but with electrical, due to electrification of that, so due to triboelectricity. And to cope with this, to tackle this hypothesis, they organize and they promote. That's why I said system approach, comprehensive approach of phenomena that they promote. They promote even LiDAR observations, of expeditions in Cape Verde, and modeling as a whole team of 20 people or more that were handling with the issue of dust, of modeling dust circulation. When you take interviews, when I was taking interviews from the group, it was clear that emphasis was how to integrate, how to appropriate and change and accommodate open source software in modeling developed by the National Center of Atmospheric Research in United States, increasing the resolution, but also coping with different sizes and uncertainties that different sizes of dust create, the lack of data from Sahara, so a lot of hypotheses about this that can be or should be integrated as parameters in the modeling, and the interaction of dust with radiation and other aerosols. Yet still, while they promote this agenda and this agenda it is promoted by the head of the team, so open science, and the head of the team is also one of the leading scientists that promote the open science agenda strategy of the whole country. While they have this agenda and this research ethos, in the same time, they bring the idea of products, of how this kind of blue sky systematic research that combines observations, instrumentation, and modeling can create products for space industry and NASA, the European Space Agency, modeling dust for urban spaces and integrating dust in for smart cities and the whole agenda of smart urban spaces, and also create products for aviation. So while they have the agenda of basic research, they promote also the idea of products for big industrial users in a way, as we have seen it as a practice, a tradition that was coming from Kallos too. To conclude, I think that the center periphery, when someone is looking to the numerical weather prediction, the center periphery distinction it appears as a much complicated story. For example, Kallos, while was building on computing capacities of, let's say, subsidiaries of American companies, or initially he was using modeling models from Colorado State University. Eventually, he built Skiron, first of all, in a Yugoslavian practice and model. And also, he started through commercialization to be a center for Middle East and the Arab world. So the center periphery really for the Mediterranean, at least the Southeast Mediterranean, is very complicated story. I argue that epistemological and social bricolage is a way to build a field. So practically, what Kallos was doing initially in the 80s and up to 2000, it was just a bricolage, just tinkering from existing either models or data or financial capacities or institutions, and bring all this together. Open code and open science, both in the case of Kallos, but also in the case of other groups in Greece, like the one in the Hellenic Observatory of Athens, is a way to construct mutable mobiles. So things that they change and they can travel, and thus link their designers to different networks. And most importantly for them, networks of users, of big industrial users. Numerical weather prediction appears to be a boundary object that needs a lot of boundary work between the world of use and commerce and the research world. And there, I think that technoscientific capitalism, since the 1980s, it appears to emerge as, let's say, an activity that promoted spontaneously by researchers and resonates a lot with developments the same period was happening in promoting technology transfer policies. And this resonance created a habitus for technology transfer. So practically people, even those who were thinking of themselves as basic scientists and as practicing basics science, they cannot think beyond technology transfer. So products can be both public goods through openness, but also assets for clients. And this appear to be inherent in the practice of numerical weather prediction, particularly for the emergence of numerical weather prediction in the Southeast European periphery, and more specifically in Greece. And with this, I would like to thank you very much.
Conclusions, I think, were fascinating because your case is very much focused and very interesting in itself. But once you get to the conclusions, one can see also the broader implications. So that was great. Thanks a lot. The floor is open for questions. Anyone? I have a couple of them, if I may start. So the first one would have to do with this idea of broadening the case that you've been doing in the conclusions. Is there something specific to environmental research and environmental products in this story? Because your conclusion seems to be in general about the research fields and techno-capitalism, but is the environment a field, environmental sciences, a field that lends itself to these kind of processes?
Yeah.
Sorry, but and also because your previous work was very much on system building and this interface between property rights and commercial use and so, and you're moving now into the field of the environment. So another way of framing the question is, what are you finding that is new in this field? Maybe.
Yeah. That's a very difficult question, Lino. I need to think a little bit. You are right that my approach has not been influenced by, let's say, environmental history at all. It links sociology of knowledge and sociology of science with history of science, and yes, I'm using tones of what I was, let's say, using for doing research in the first half of the 20th century. Now that I moved to the second half, and more particularly to the last 40 years, the analytical tools are more or less the same without opening to other, let's say, genre of history, like environmental history. But for me, I think the fascinating thing with this research is that when you go and interview this, and because I have conducted many interviews with several forecasters in Greece, and also leaders or researchers or even popular meteorologists, and particularly for the researchers, you can find the different agendas and different research agendas. It is surprising that since the 1980s, while they promote an understanding of atmospheric physics as basic research, in the same time, for example, Kallos was well immersed into the idea of using this knowledge and this expertise for large-scale users and industrial users in his case. And the same applies for the other leader in the observatory, Athens Observatory. So for me, the key point is to understand, and this is something that I'm working in other domains also, for example, agriculture and other research with other research teams, the issue of technoscientific capitalism in Greece. This is something that really fascinates me at the moment, and I believe it plays a key role for the 40, 50 last years of research policy, because through technoscientific capitalism, or due to the emergence of technoscientific capitalism, a lot of research groups really became centers in European periphery. So for me, I see this technoscientific capitalism as an emergence, as I said, a spontaneous emergence from research networks, and rather than from industrial networks as in other countries. If I see it as particularly a characteristic in the environmental science, I would say no, because we have another project on food, and a third project on sciences, and there also people who are working with me, PhD students, they conduct sociological research in research labs, and it is clear that research labs in those scientific fields, since the mid-1980s, they promote this agenda of, we don't have money, we need to, let's say, find a way to survive, to put it very simply. And there you have different agendas in different research groups, but all together with the fragmented research policies of the state, Greek state, they eventually let's say, result to what I argue as the technoscientific capitalism as habitus, technology transfer as habitus in research ethos. So as something that you cannot think yourself outside this. And this is what is happening either in biosciences, and that is our argument actually, in food, but also in atmospheric physics. I don't know if I
Thank you.
like.
Yes, thanks. Yeah, that was I was looking for. I have another question while other people think, which has to do with, because as you know, we in DeepMed we care very much about the Mediterranean Sea proper, yeah. And you mentioned that the Pablo is saying that his internet connection is not great, so he's asking a question online. We'll read it later. He's in the UNESCO archives in Paris, in the basement, apparently. So my question is, because the model Skiros that you were talking about takes into account topographic and climatic specificities, whether you know what kinds of parameters were they adding that were related to the Mediterranean Sea proper, either topographical or climatic.
Skiron, when it was developed, and it didn't had any parameters about the sea. But in 1999, and this is a side story that I didn't cover because this would divert to a completely different story that I'm covering in my research. Kallos with the National Marine Institute, they developed the project Poseidon, which is particularly for the sea. So they adjusted Skiron, particularly for ski, and Poseidon is a model taking into account measurements about waves, tides, precipitation in different levels of above the sea, and at least at that point there was no discussion about the seabed, while in one of my last interviews with the guys from the Marine Institute, they told me that they started to integrate in Poseidon system also information about the seabed and how this influenced the waves and blah blah blah. So this is the Poseidon story, that it is linked also with pressures, challenges that is coming from the navigation and the ship owners, that they wanted a credible system, a numerical weather prediction system for this area, and information to be arrived in the ships. So this is the story of the Poseidon project that was built by Kallos and as a spin-off of Skiron.
Wonderful. That would be great to look at in more details. Thank you. So let's go to Pablo's question in the chat, which says, back in the 1980s and 90s, what was the international body, if there was anyone at all, coordinating the making of air pollution models between Greece, Israel, and Turkey? Were there other Eastern Mediterranean countries either excluded from this research network or not willing to participate? And then from the oceanographic experience, I know that Egypt, Libya, etc., they lacked capabilities and expertise, and they relied on UNEP funds and training. So let's start with the first question, and then we will go to the second.
Yes. Just to, I open the chat just to see once more the question.
Yes, absolutely.
Look, about the project, about the air pollution, yes, air pollution in Southeast Mediterranean. This was the first project that I have found about air pollution in Southeast Mediterranean, and this was involved also aircraft collection of data from aircrafts that were traveling in this area. There were instruments in the aircrafts that then all the data were collected in the University of Athens. I know for sure because I was when I interviewed people, Kallos and also his people, I know that there was a big interest by Egypt, and it was a keen interest even in the early 1980s about numerical weather prediction by Egypt. But as it has been mentioned, Egypt was not, at least according to Carlos, and I haven't looked international archives, but Egypt didn't have the research capacities and credible academic centers to run this kind of research projects, at least according to Carlos. While Turkey and Israel, they were very credible, thus the alliance and the project. And it went that good that for Carlos, since the early 1990s, he used to get data more easily by Turkish researchers and the Turkish Meteorological Service rather than the Greek Meteorological Service. As I said, there were conflicting interests and different approaches about how to deal with data and coding. But in relation to Egypt, this is what I have so far.
Wonderful. Second question by Pablo. Were there any shared concerns with the Mediterranean oceanographic community regarding pollution? Marine pollution was a hot topic in the Med Sea during the 1980s.
I don't know. I'm not, yeah. This is a very good question, extremely good question. This is a question that I can answer it for the early years of the new century, so 2000 onwards. But for the 80s and 90s, because I was following specific research groups in Greece and didn't appear the whole international or North African networks. I haven't looked at international archives. Actually, I didn't have access to international archives, and I didn't mean to go. I didn't plan to go to international archives because the research questions are very specific in my research. So it's a fantastic research question, but I don't think that I can answer this.
Okay, Ayman has a question.
I also have a question. Oh.
Thank you very much for the presentation. Just I will appreciate if you can clarify. In your presentation, you mentioned that at some point they start integrating topography data. My question is, do you mean bathymetry data, or do you mean topography from land, or
No.
phototopography?
Topography from land, mountains, precipitation and temperatures on mountains, and this kind of data. Data from land and precipitation, as I said, pressure and temperature in different heights from the sea level and onwards and up. So no bathymetry data.
But then you mentioned that they start now to include some information from seabed.
Yes, indeed. For the Poseidon model, which is a model about prediction of sea circulation, water circulation, and tides, waves, and atmospheric circulation on the surface of the sea, the Mediterranean Sea.
But bathymetry too, or not?
Bathymetry too, recently, not in the 1999 when Poseidon was designed.
Okay. Thank you for the clarification. Thank you very much.
Effie, also from Athens, is going to ask a question, and then Alessandra.
Hi, Effie, nice meeting you.
Nice meeting you too. So thank you very much for this great talk. I learned so much for things that I obviously previously ignored about weather modeling system development and establishment in Greece. So my question takes us to the very first part of your talk, an instance in Kallos research that you mentioned briefly. So my question is about smog research, and I'm asking this because growing up in Attica, not Athens, in Piraeus in the 1980s, the whole smog issue was very prominent everywhere. People, like you said, were discussing it. I was a kid back then. I remember being referred to smog as something very toxic, hazardous, blah, 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 even though in Piraeus it wasn't so much a big deal as it was in Athens, as you know. So I was just wondering if you could elaborate a bit more about these early years of smog research for the wider Athens metropolitan area. What were other stakeholders involved? Was the municipality involved in some way? Because you showed some pictures from the press, was Kallos and his team prolific in the press? I don't know, I was very young back then. How were they portrayed in the press? Did they work in the shadows of, So that is my question.
Thank you, Effie. That is a nice question. I referred to what I called, let's say, instances or vignettes of the research activities of Kallos, and I referred to three those instances. In order to understand and also show that Kallos developed in the 1980s when he came from the US a specific, let's say, research style, which is I am modeling. I'm modeling the weather and try to introduce physical parameters and parameters from the terrain. And this is something that presumably the education was important, but the first instance that he had this challenge was try to develop a model about the environmental prediction of the industrial plant. And the second research style, let's say, the second characteristic of research style is distributed memory. And he first set this idea of distributed memory when he approached IBM in order to develop this model about the Athenian smog. He set a, let's say, not only a collaboration, but a friendship with the head of the IBM Hellas, the subsidiary of IBM. What you are asking me, it's a big topic that I had already talked in the European Society for the History of Science. The smog, the Athenian smog, is a big story that involves research labs in the Polytechnic School of Athens, the Technical Chamber of Athens, uh, governmental departments and ministries, as well as non-governmental organizations and citizen science initiatives that they set their own data from measurements that they got from different regions or neighborhoods in Athens. So it's a very complicated long-term story from the 1978 when it started a whole discussion by the UN and the project that they set in order to map the pollution and the sources of pollution. So there was a project there. And it went up to the early 1990s with new technologies in cars, but also with new policing technologies like the congestion cycle, how it's called, dactylios, so the congestion cycle. So it's a very much different story where Kallos was very marginal, I would say, although in the interviews he was claiming, let's say, a role in predicting the distribution of pollutants in the region of Athens. From my other research, I haven't found it. So it's just a narrative that he wanted to build. But for my story, it is important because of the style of distributing memory. I mean, my argument is that you have people in the European periphery that lack infrastructures, so they change the research agenda in order to cope with this and turn this into an asset. This is my argument. And practically, this change and emphasis really make empower Kallos in his plans to see and move towards Southeast Mediterranean and the Arab world.
Thank you. And a very quick question. I'm just curious. It's a fun fact question. you mentioned that you also interviewed popular meteorologists, so I'm just curious. Which ones, if you want to share, of course.
No, I have two interviews of those popular meteorologists who are appearing in several channels in Greece. So yeah.
Γνωστούς, διάσημους.
Yes.
Okay. Thank you.
Thank you for the question.
Sandra, please go ahead. I think you had a question, right?
Yes, thank you. Yes, right. Okay, so I have two questions on weather prediction, weather modeling. I was curious to know whether stakeholders in different countries were perceiving weather prediction and weather modeling as equally sound and deserving governmental funding. This is the first. And then you mentioned it at some point, the training of some scientists coming from the Maghreb region in either in Greece or somewhere else. And I was wondering whether this training was an unidirectional transfer of knowledge, or you think there were some elements that were incorporated into the models, or at least into the theory of weather prediction that comes from local scientific tradition of weather studies. Thanks.
Can you repeat the first part of your second question, because there was a
Sure.
lack of the reception and the signal.
If I'm not wrong, at some point you said that some scientists from the
So it seems that there is a problem. Alessandra, you can either write it on the chat, or Stathis, you can also answer the first question and then we'll go to the second one. But if I understand, sorry, Alessandra, we lost you and then you're back.
Okay. Lino, maybe you can try to repeat the question if you want, because I'm afraid my internet connection might be not very well today.
You can type it
I
on
can
the
type
chat
it. Okay.
while Stathis answers the first question. Would that make sense?
Okay. Thanks.
Yeah. The first question is an excellent question, very nice question. I really like, and this really is a very important historical question. About weather modeling, I don't, for Greece, I don't think that there were a state awareness about the importance of numerical weather prediction and the, let's say, the importance of weather numerical prediction and whether they had to support it. As I said, they had a challenge to shape a science and technology policy. This challenge, let's say, pushed forward since the 1982 and during the 80s. And in this context, they promote the integration or the linkages of industry with research facilities and research groups. So in this setting, Kallos had to persuade the General Secretariat of Research and Technology to give the money. So I don't think there was an awareness from the state. The awareness is coming with the Olympic Games. Really, there there was a big concern, and weather prediction was a concern for the state, and it was one of, let's say, the criteria for the evaluation of the services provided during the Olympic Games. As in relation to the other countries, I think the most important for research group, the Kallos research group, was the networks that he was building and his research lab with industrial actors, and from there he persuaded the local states. So the networks really create numerical weather prediction as a matter of concern. And the industrial networks really played a key role in networking him to the state. As for the second group or other groups that who are working on numerical weather prediction with an emphasis on dust particularly, I think that since the 2010 onwards, there is a key interest from international organizations about dust and dust circulation. So the international diplomatic networks set by those scientific institutions really create dust and dust storms as a key matter of concern and as key research topic for, let's say, research institutes in the northern coast of the Mediterranean. The second question is training from North Africa can be considered as a unidirectional transfer of knowledge, or you think there were some elements of their local scientific traditions that were incorporated into the broader theory of, oh, that's a fantastic question. Very nice question. But I need to stress that in order to answer this question, you need to see the migration of numerical weather prediction in those countries. So rather than the training per se or the context of the training, you need to see how numerical weather prediction and the expertise they got from those training courses in Sicily migrated to the local context. So there I can see how they adapted all the expertise they get and the modeling expertise into the actual domain of forecasting in real time and given the terrain and the specificities of the topographical and geographic specificities of each country. I don't know if I answer you, but excellent questions.
Yes.
I really love them.
Yes, totally.
Okay, so thank you very much, everybody. We're past the time, so I think this would be a good moment to wave goodbye, and we'll see us very soon. Thanks a lot, Stathis, again.
Thank
for
you
your-
very much, everybody, and thank you, Lino, for the invitation. And once more, I apologize for not being able to be there with all of you. It would be nice to have a nice glass of wine afterwards in Sevilla, but I promise on another instance or chance. Thank you so much.
Exactly, next time.
Thank you.
Thank you. Thank you very much. Okay.
Hi, guys. Thank you.
See you soon.
Bye-bye.
Bye.